Good morning, everyone. Welcome again to my YouTube channel. This is Shago. I want to welcome all our first-time viewers and those who are joining us for the first time. Please take a chance and dial that subscription button. In today's episode, I want us to dig deep into geographical facts, and I want us to look at the Earth movement. From our primary or high school knowledge, we understand that there are two types of Earth movements, that is horizontal and the vertical Earth movements. In high school, that is in Form 2, we learned we were introduced to two types of theories which tries to explain Earth movements. That is continental drift theory, that was suggested or proposed by Alfred Wegener, and also we have the plate tectonic theory, which is an advancement of the Alfred's theory of the continental drift theory. And in the continental drift theory, we looked at the causes of Earth movement, though that is not the part I want us to look at today. Today I want us to talk about the plate tectonic theory. But we must start from the continental drift theory because that is the base for the plate tectonic theory, because I said that the plate tectonic theory is the advancement of the continental drift theory. So for us to understand the plate tectonic theory, we should go back to the continental drift theory, and we understand first what causes the Earth movement. So in the continental drift theory, we understand that there are four causes of Earth movement, four major causes of Earth movement. One we said was magma movement. Another one we said was convectional current within the Earth's mantle. Also, we talked of the gravitational force, and also we talked of the isostatic adjustment. I don't want to go deep into those causes of Earth movement. I think up to this point, you know the causes, and at least you can briefly explain the causes of the Earth movement. So in the continental drift theory, Alfred explained that the Earth was once one landmass, and due to those forces which causes the Earth to move, the Earth split into several crusts. Those crusts are what we call the plates, right? The Earth was once one, and it split into several parts. So those several parts are what we call the plates, right? Those are what we call the plates. So in today's episode, I want us to talk about this advanced continental drift theory, which is called the plate tectonic theory. Welcome. So in the introduction of the plate tectonic theory, I want us to understand first the basic definitions so that we can vividly understand what plate tectonic theory is all about. So when you talk of the plate tectonic theory, it is a theory which was put forward to try and explain that there is a movement within the plates. I said Earth was once a one landmass, and due to tectonic forces, or due to the four causes of Earth movement that we talked about, the Earth split into several parts. Those several parts are what we call plates. Plates. All right? And we have two types of plates. We have two types of what? Plates. One is continental plates, and two is the oceanic plates. One is continental plates, two is what? Oceanic plates. So oceanic plates are those parts of the Earth which are submerged underwater. are those parts of the earth that are submerged what? Underwater. It means they carry water above them. And we have the continental plates. These are plates which float over water. All right. So we have the continental plates and the oceanic plates. Those are the two types of plates in the tectonic theory, or in the plate tectonic theory. So let us give examples of these plates. Number one, we have the African plate. Let me tell you, okay, like the continents we have are the plates. In plate tectonic theory, they are called what? They are called plates. So number one is African plate. Number two is Antarctic plate. Three is Eurasian plate. Eurasian plate is where we have Europe. Eurasian plate. Also we have Australian plate. We also have North American plate. Also we have Pacific plate. Now when we talk about the Pacific plate, this is now the oceanic one, oceanic plate. Also we have the South American plate. Yeah, the plates are several. We have the oceanic and the continental. Another oceanic plate is what we call the Nazca plate. Nazca plate is found down next to the South American plate, around the Andes mountain. So those are the plates. So according to the plate tectonic theory, it is believed, or geographers come into agreement, that these plates are in constant movement. These plates are in constant movement. More specifically, in this theory, the cause of the plates to move, the cause of the plates movement in this theory is the convectional current that is found in the asthenosphere of the Earth's crust. That is in the mantle of the crust. So it is the currents which moves in a circular manner, exerting frictional drag onto the Earth's crust. This frictional drag pushes the Earth's crust apart, hence causing a movement. So in this plate tectonic theory, we have three types of boundaries. We have three types of what? Of boundaries, or boundaries. So in these types of boundaries, but there's something I need to let you know. That I said we have two types of plates, continental and oceanic plate. So these two plates are of different characteristics. Number one, continental plate is lighter, that is not heavy, while the oceanic plate is very heavy. Why is it heavy? It is heavy because it carries water. Okay, the water volume is added onto it, so it is very heavy. Right, so let us go now to the boundaries. The plates, or these plates, are believed to be moving towards, away, or past each other. Good. There are three types of movement involved in plate tectonic. So these plates can move either towards each other, or away from each other, or past each other through a parallel line. All right, so these plates can move in three directions: towards each other, away from each other, and past each other. So these types of movements, or these three types of movements, brings the three types of boundaries in a plate tectonic theory. Boundary number one, we call it the convergent boundary. The convergent boundary. Convergent boundary comes from the word to converge. That is when plates come together. All right. So a boundary that is found between plates which are coming together is called convergent boundary. It is called what? Convergent boundary. So convergent boundaries are also called constructive boundaries. Why are they called constructive boundary? They are called constructive boundary because their movement towards each other leads to the formation of new landforms. Why? They are called constructive boundaries because when plates move towards each other, there is a formation of a new landform. There's a formation of a new feature, hence constructive. There's a construction of a new thing. All right. So let's look, for example, we see, I want to give you two types of convergent boundaries. One, when the Nazca plate, I said Nazca is a oceanic plate that is found down the South American side. So when the Nazca plate moves or moved towards the South American plate, when the Nazca plate moves toward the South American plate, the sediments that was found in between the Nazca plate and the South American plate was pushed, all right, towards each other, and instead of cracking or instead of splitting, the sediments in between, the gap between South American plate and the Nazca plate, they bended, okay? They bended. So the movement of the Nazca plate towards the South American plate bended some rocks or some sedimental rocks that was found in between to form what we call the Andes Mountain. What we call the what? The Andes Mountain. But the Andes Mountain is found in the southern part of South America, around Chile, all right? Around Chile is where we have the Andes Mountain. And it is a mountain range. So Andes Mountain was found out of Nazca plate coming together or coming towards the South American what? Plate. So the South American plate and the Nazca plate coming together, they formed what we now have as Andes Mountain or the Andes ranges. Number two, when the African plate moved towards the Eurasian plate I told you is the Europe, right? So when the African plate moves towards the Eurasian plate, remember, between African plate and the Eurasian plate, there is a sea called Mediterranean what? Sea. So Mediterranean Sea is a gap in between Eurasia plate and the African what? Plate. By the let me tell you, the gap that is found in between, be found in between two plates is called a geosyncline. Gap, or that space between two plates is called what? A geosyncline. By the way, this geosyncline or this gap is always being filled with sediments. Sediments from where? When glacier, okay, when glacier freezes down or freezes, not freezing like when like I'm saying, like when glacier melts, remember when glacier melts, it turns into water, and as it runs down the highlands, it picks some debris or some materials, and it deposits this what? Down the sea. Also, we have some rivers which come from the uplands of the sea, both from Africa and from Europe. When they move down their valleys, they erode. As they erode, they transport. Where do they deposit? In the syncline, or in that what? In that valley, in that gap. So that is where we have the sediments. That's the source of the sediments. So when the African plates moved towards the Eurasian plate, it pushed, okay, it compressed those sediments. It compressed those sediments so much that they what? That they started to bend. Remember, sediments or rocks that are formed out of sediments are ever young. They are young rocks which are not easy to break because they are elastic. They are elastic rocks. So when elastic rocks are subjected to high pressure, they bend instead of what? Of cracking. So the sediments or the sedimentary rocks within the geosyncline that is found in between Europe or Eurasian plate and the African plate, when they are subjected into high pressure, they what? They fold. So when African plate moved toward the Eurasian plate, it pressed the sedimentary rocks in between or in the geosyncline to fold, forming two mountains. And these mountains are fold mountains. Mountain number one, which was formed out of this movement, is called the Alpine in Europe. Another mountain that was found, that was formed out of African plate moving towards the Eurasian plate, is the Atlas plate. Atlas, you know where Atlas is found. Atlas is found in the what? In the Morocco, or in the country of Morocco, northwest of Africa, there at the north. Okay, so that is the convergent type of boundary. Convergent is also called constructive. Constructive because it brings into being new features. So it is called, it constructs the boundary. It converges. So it is called convergent boundary. So, right. Boundary number two is to call divergent boundary. A divergent boundary. Divergent boundary is formed when two plates moved away, or it moves what? Away from each other. When they move away from what? From each other. These boundaries are also called destructive boundaries. They're also called what? Destructive boundary. Because they destroy. For example, is the Atlantic plate. That is the oceanic one. Okay. The divergent plates are normally found within the sea. So in the seafloor, we normally have what we call the seafloor spreading. The seafloor what? Spreading. Seafloor becoming wider and broader. Why are they coming wider and broader? Because there's a movement. Okay, new rocks are being exposed as plates moves away from what? From each other. So in a place where two plates moves away from each other, there is what we call a destruction. There is something which is being destroyed. One, the crust is being broken into two. The gap that was in between them is now being split further. It means something is what? Is breaking. So, for example, when you take something like a rope and you pull it from both ends, when the pressure is too much, what happens? It breaks. It destroys that feature. It destroys that thing. So divergent boundaries are also called destructive boundaries because they destroy what was initially there. They destroy what was what? Initially there. For example, when plates moves away from each other, there's what we call crustal break. The crust will break, creating a fault or a crevasse. Remember, below the crust, below the lithosphere, there is what we call a stenosphere, which is the mantle. The mantle, inside the mantle, we have a molten rock called magma. When magma, remember, magma in the mantle is under very high pressure. and temperature. And magma in the mantle is in continuous movement. So when the two plates move and creates a crevice or creates a crack, what will the lava do? The lava which is downside there, it will try to come out. It will try to push itself out of the magma chambers. Because I said the pressure in the mantle is very high and the temperature. And the magma is in constant movement in a circular manner. So when it finds a crack above its sailing, what will it do? It will try to move out. So when divergent or when plates move away from each other, there are creations of new thing. One, the crack will the crust will break, then the magma will come out through that what? Through that crust. And when magma comes out, we have two types of magma: acidic and what? And basic. Acidic magma cools very fast and it explodes very violently. Why? Because it has gaseous material. It contains very many gaseous what? Material. We call them the silicates things. Okay. So the acidic magma will always come out violently and it cools very fast. But if you want to differentiate between an acidic dome, volcanic dome, and a basic volcanic dome, very simple. Acidic volcanic dome is very high, okay? It moves very high. It has a height, all right? And its slopes are very deep, very steep. While the basic cone or the basic volcanic cones are very their slopes are very not that deep. Okay, you can walk over it, you can cross it with a bicycle. Yeah, so that's the difference. So when acidic magma finds its way through these cracks, it will pile into the sea. When it piles into the sea to that height, it will form what we call, or it will continue piling until it comes out of the sea to form what we call volcanic oceanic islands, or what we call oceanic islands. So maybe some of these islands we see in the ocean there as a result, some are as a result of divergent type of movement. When plates diverge or when they move away from each other, they create a crevice, they create a crack. This crack, magma will come out through it and piles to form what? To form a mountain in the sea. When it comes out of the sea, it calls or it forms what we call oceanic volcanic island, or oceanic what? Island. That is divergent type of movement or type of boundary, which is also called destructive boundaries. Boundary number 3. So boundary number 3 is what we call the conservative boundary. The conservative boundary. The conservative boundary. Why is it called conservative boundary? When we say you conserve, it means you leave something at its status quo. All right? Status quo is the way things are. So conservative boundary is that boundary that is found when plates, okay? It is formed when plates moved past each other. When plates slide past each other. When plates slide past each other, there is no formation of new feature. There is no destroying of what? Of a feature. What was there remains what? Remains there. So it is called conservative boundary. What again should we know about plate tectonic theory? Let us give now a summary of plate tectonic theory. So in plate tectonic theory, we said the plates moves in three different what? Directions. One, moving towards each other. Two, moving away from each other. Three, moving past each other. It is these three types of movements which leads to the three types of what? Boundaries. Where I said when plates come towards each other, it forms a boundary called convergent boundary. And I said that convergent boundary leads to the formation of new what? Of new landforms. So convergent boundary is also called constructive boundary. Then we have the divergent boundary. In the divergent boundary is where plates come or moves away from each other. When plates moves away from each other, it destroys what was originally there. Hence the name destructive boundary. Right? Then we have the third boundary called the conservative boundary. The conservative boundary is a boundary that is formed when plates slide or slip past each other in a parallel lane. So in this boundary, no formation of new feature and there is no destruction of a feature. So it is called conservative. And I said conservative means maintaining the status quo. It is also within these boundaries where we have a lot of earthquakes taking place because there's a lot of pressure, right? Along the boundaries we have pressure. So when pressure is there, we also have a lot of breakage. So along these boundaries is where we have lots of earthquake, earth tremor. We also have the volcanic activities taking place. Yeah, so within those boundaries, I think along the boundaries are not good for human settlement. Yeah, humans are always being told to move away from such boundaries. But there's something I forgot to tell you, that when place moves away from each other or towards each other, but I want to talk of away from each other, there's a breakage. Okay, this breakage will lead us deep into the asthenosphere. When they move away from each other, it leads to the formation of what? Oceanic trenches. Trenches are the deeps in the ocean or the valleys in the ocean, like the Mariana what? The Mariana Trench, the deepest trench in the world, Mariana Trench. Yeah, that's what I wanted to add. That trenches are also being formed when plates moves. So that is all about plate tectonic theory. If you have any question, any addition, please feel free to comment. Until next time, this is Jaushago.